Okay, this is your 10-question review of volume. Um, Remember, for volume, it's really not a difficult thing compared to surface area. Surface area, we had very complex formulas you had to kind of think about. There was a lot of calculations you needed to do. But what we said at the start of the volume unit is it's very easy because for all of these formulas, there is only one formula you need to use. And that formula is this right here. The area of the base times the height of the prism will be the volume of any right prism. So the answer is true. And what we mean by that is if I had a rectangular prism, or if I had a cube, or if I had a triangular prism, or if I had a cylinder, in all four of those cases, all I would need to do is find the amount of cubic centimeters that fit in the first level, and I would simply multiply that by the height of the prism, and that would tell me how many there were. So let's say this is 1, 2, 3, 4, 5, 6, 7, 8. This is 9 centimeters by 1, 2, 3, 4, by 4 centimeters. That means that on that first level, or the area of that base, is 36 square centimeters. Multiplied by 1, 2, 3, 4, 5, that's 36 square centimeters, multiplied by the 5 levels that are in that prism, means there is 180 cubic centimeters inside there. Okay? So the area of the base multiplied by the height of the prism would be LW, because it's a rectangular prism, multiplied by the height. It would be 9 times 4 multiplied by the height, or it would be 36 times 5, which would tell me the volume as being 180 cubic centimeters. Same thing holds true with cubes. This would be a 4 by 4 by 4. The area of the base would be area of the base, which is a square, not a rectangle, multiplied by the height of the prism. It would be 4 squared multiplied by the height. It would be 16 on the first floor, multiplied by the 4 floors, would mean there are 64 cubic centimeters inside that cube, which is actually an answer to a question, I think 8 or 9. The difficult thing becomes when we deal with prisms like this, because when we look at, let's say, this one, the area of the base is kind of, you have to think about it as being a triangle. So for this one, we need base times height divided by 2 multiplied by the entire height of the prism. So this B is this 10, this H is this 5. These 7 and 8, as far as volume is concerned, is superfluous pieces of information. We need to think of this as being a 10 times a 5 divided by 2, which is 25 centimeters. So this top part has an area of 25 centimeters squared. And then, even though I can't see it, the base is also that same triangle, which is 25 centimeters squared. That's the area of the base multiplied by the height of the prism, which in this case is this distance right here, means that the volume, if this was centimeters again, the volume of that triangular prism would be 100 cubic centimeters, and so on and so forth. Same thing with circles. Instead of being area of the base, we're going to have a pi r squared, which is the area of your base, multiplied by the height of that prism. Okay. Question number 2 says a cube with a base of with an area of 64 centimeters squared has a volume of 512. So let's draw a cube first. First thing you should probably do is draw the cube. And the base, I'm going to do it up top here. The base was told to be 64 centimeters squared. Now, if you know the area of a square, you should be able to calculate its side length by using square root. So the square root of 64 is 8, which means that all of the measurements of this cube are all 8s, right? If the area of the square base is 64, then therefore the edge length is 8. So the area of the base is given to us at 64, multiplied by the height, which we know, since it's a cube, has to also be 8. And when I multiply that out, I get 512. But be careful. Centimeters cubed is your answer. And it clearly says in the question, the volume is 512 centimeters squared. So your answer for question 2 is a very tricky and unfortunate false. The number is 512, but the units are centimeters cubed, not centimeters squared. Yeah, some bugger who made this test made that question just like that. Actually, to be honest, it's a misprint. I didn't mean for it to be that, but technically the answer would be false. So when I made it, I got to go back and change that up. It is 512 cubic centimeters. So if you said true, I'd probably give it to you because it was a misprint. Question 3 is important, and it's definitely true. And when we gave you that one little yellow cube of plastic, it was 1 centimeter by 1 centimeter by 1 centimeter, and it was 1 centimeter cubed of space. And we said that if that was not made of plastic but of water, it would be exactly 1 milliliter. It's a very important measurement. And the metric system is actually based on 1 cubic centimeter of water being 1 milliliter. That's where a milliliter comes from. Okay? And just as a side fact, the mass of 1 milliliter of water is where we get the unit a gram. A gram comes from the mass of 1 milliliter of liquid, of water, excuse me, not liquid. Question 4 is an easy one. Changing the orientation of a prism affects the volume. The answer is false. Just because I lay a container down on its side does not affect its volume. In both of these cases, the volume would be 200 centimeters cubed. Right? So the volume does not change if I lay it down on its side. Question 5 is, what is the volume of this cube? So for this one, we need to use our formula. It's the area of the base times the height of the prism. So the base in a cube is going to be a square. So I need to use side squared for my formula, multiplied by the height of the prism, which I technically could use s again, but I won't. So 5 squared multiplied by the height, which is not written, but we know it's 5 because it's a cube, will be 25 multiplied by 5, which will mean that in that cube there would, meters, not centimeters, there would be 125 cubic meters of space inside that cube. Now, if that was a swimming pool, a 5 meter by 5 meter by 5 meter swimming pool, it's fairly deep, we know that that would have a volume of 125 cubic meters or 125,000 liters, because 1 cubic meter of water is equal to 1,000 liters. 1 cubic meter of space holds 1,000 liters of water. Okay, that's just an aside as well. Question 6, what's the volume of this? Same formula, area of the base, which will be a rectangle, multiplied by the height of the prism. It'll be 100 multiplied by 5, multiplied by the height, which is 25. This will be 500 multiplied by 25, which will be 125 plus 2 zeros. So 12,500 cubic meters. Or, if I was to put 3 more zeros on there, 12,500,000 liters. If that was a container, a lot of liters. Question 7 is a little unfortunate that I did it this way, but what I'm going to do is I'm going to take this and I'm going to rotate it so you see it a little bit better. Some people see it better when it's in tent form rather than on its side. So when I think about a triangular prism, what shape is the base? A triangle. So therefore our formula will be this. Now since I have an H here and I'm going to have an H here, I want to make sure I differentiate between the H's by I'll use a capital H there. And then I'll say, okay, I'm going to redraw my triangle here. 3 and 18. So the base is 18, the height is 3 divided by 2. That will be 30, 50, 54 divided by 2, which will be the area of this triangle right here, and I'll return it around again. The area of this triangle here is 27 square meters, which means the base that I can't see is also that triangle, which is also 27 square meters, multiplied by the height, which is 10, means that the entire triangular prism has a volume of 270 cubic meters. Okay? Very important you put cubic meters, not square meters. Because square meters, as we all know, is for surface area. And it would be very unfortunate if you use this formula for the volume of any prism, because of course that is the formula for the surface area of a triangular prism, which is what I would need if I was painting it, not if I was filling it with water. Question 8, what is the volume of this cylinder? Well, I still need to use area of the base. Since the base of a cylinder is a circle, I will use the area of the base being pi r squared, multiplied by the height. It says use 3 as pi, make it easier on us. Now the radius of this circle, if the diameter is 10, the radius will be half of that. And I have to do exponents first, so 5 squared is the first thing I'm going to do, which is 25. So the area of that circle, right here, is 75, which means the bottom circle, or the base, is also 75. I'm going to then multiply it by the height of the prism, which is 2. And I learned that the volume, or the capacity of that particular cylinder, is 150 cubic centimeters of space. Okay? Question 9 is a little puzzle, but really if you paid attention to question 1, when I was doing it in the show, you know, or in the first one, you would know this one. But I know that it has an edge length. I know the volume is going to be 64 cubic centimeters. And I know that's going to be x times x multiplied by x. Because it's a cube, all of those x's are the same number. So really, x times x times x, as you will learn in grade 9, is really x cubed. But I can try different numbers. So I'm going to just trial and error. And I'm going to just try the number 2 and see what happens. If I put 2 there, then the area of the base would be 4. And 4 times 2 would be 8. The volume of this cube would be 8 centimeters cubed, which is not appropriate. So it's not 2. But it's got to be more than that. So I'll try 5. 5 times 5 is 25. So the area of that base would be 25. Multiplied by the height is 125. That's too high. But I'm getting pretty close. I'm going to try 4. And when I try 4, 4 squared is 16. Multiplied by the height, which is 4, I get 64 centimeters cubed, which means that the edge length must be 4. 4 times 4 times 4 is 64. Now, if you wanted to use a calculator, there's actually a button on your calculator, and it's right here. Oh, no, it's not there. Oh, yes, it's right here. There it is right there. So the cube root button, this is the square root button right here. Oh, hang on. It says cube root. I'll press clear. The square root button is right here. That says square root. But the cube root button, if I was to put the number 64 and said what number multiplied by itself 3 times, or the cube root of 64, it would tell me the answer already. It says 4. So it says what number multiplied by itself 3 times is 64. So you could use a calculator for that if you had one. And finally, the last question says, this rectangular prism is 2/5 full of water. How much water is in the prism? Well, the first thing I'm going to do is just figure out, not if it's half or 2/5 full. If it's full, what would it be? So the length would be 18. The width would be 8, multiplied by the height of the whole prism, which is 14. 18 times 8 is 64, and 80, which is 144. Multiplied by 14. Can't do that in my head. So I take my calculator. 144 times 814 is 2016. So the volume of the full prism is 2016 cubic centimeters, right? But this is only 2/5 full. So 2/5 of 2016, and we know that 1 cubic centimeter is a milliliter. So really, I'm looking for 2/5 of 2016 milliliters if it was full. 2 ways you can do it. You can convert this to a decimal. So 2/5 is 4/10. Of is the word is really multiplication. Use my calculator to figure out 40%, or 2/5 of 2016 is 806.4. So therefore, the amount of liquid in this, since it's 2/5 full, actually that's a bad picture, isn't it? Because it obviously looks like it's more than half. Yeah, that should be 3/5. Anyway, therefore, the amount of water in that container, since 1 cubic centimeter of space is a milliliter, is 806.4 milliliters of water. Okay. Now there is a second way of doing it, and I'll show it to you real quick. What I could have done is, since this is 2/5 full, the height of the water is also 2/5 of a full height. So 2/5 of 14 would tell me how high up the water is. So if I take 2/5 or 40% of 14, 5.6, thank you. It's 5.6. So really, the height of this would have been 5.6 centimeters. Okay? And because I know that, then what I can do instead is go length times width times height, 18 times 8. But this time, instead of using 14, I can use 5.6. Because that's what the height of the water is. And if I take my thing and go 144 times 5.6, which is the height of the water, I still get the same answer of 806.4 milliliters.